everyone. In last video, I covered the topic Kolmogorov axioms, and in today's video, I'll cover permutation combination. It was an easy topic only, mostly covered in our 11th classes, so nothing much to go in deep in this right now. So let's begin. Here, probability. Probability of any event can be represented in a way of event modulus upon sample spaces modulus on finite or equally likely sample spaces, right? So probability reduces to counting how many outcomes are in event, how many total happened, like that. Okay, so when we talk about permutation combination questions, just ask yourself before the question you start, does in the question order matters? If it matters, use permutation, and if it does not matter, use combination. Everything else like multinomial, stars, bars, etc., whatever concepts are there related to this are built in these two concepts only. That order matters, use permutation, order does not matter, use combination. Next thing is there is a multiplication rule which says if task 1 has m ways to be done and task 2 has n ways to be done, together they will have m into n unique combinations and ways to be performed. Okay, moving on forward, there's something like permutation. Okay, here is like ordered arrangement of k items from n distinct items. And how you represent the formula is like n factorial by n minus k factorial, where n is the total number of items available and k is how many you are arranging. And in this case, order really matters. So ABC will not be equal to BAC. Okay, and there is one special case which we have to keep in our mind is like when all n items, when we are arranging all the n items, then the permutation will be n factorial. Okay. Moving forward, combination. An unordered selection of k items from n and how you represent the formula n factorial by k factorial into n minus k factorial. Okay. We can also read it as like n choose k. Okay. And in this thing, order does not matter. So ABC is equals to BAC, BAC is equals to CAB, and all are the like same selections. Then now next thing is Hmm. What is the relationship between permutation and combination? So just numerically you can see like combination will be equals to permutation upon upon k factorial. Okay, like divide out the k factorial, ordering you don't care about. Okay. Next thing is yeah, so there are some key identities. These are useful. Okay, so there is one thing identity, symmetric identity, which say that n ck is equals to n c n minus k, means choosing k to include is equals to choosing n minus k to exclude. You understood? Let me repeat. Choosing k to include will be equal to choosing n minus k to exclude. Okay. In this slide, I guess it's not written here. Yeah, this symmetry identity. Here it is. Next thing is boundary. Boundary says there is one way to choose none and there is one way to choose all things. Okay. So here you can write it like combination of n0 is equals to combination of n into n. N comma n is equals to 1. Okay. Then comes uh, Pascal's law. Where it is? Just a second. Yeah. So there is one thing, Pascal's law, which says that nck into n minus 1 ck is equals to n minus 1, nck is equals to n minus 1 ck minus 1 plus n minus 1 k, means items n is either in or out. And how you can represent it, let me say where it's written. Yeah, it is also called as Pascal's rule. See, here is the formula. Right? Now, next thing is binomial theorem. Binomial theorem, what it says is um, summation from n k equals to 0 to n of nck will be equal to 2n. It simply means that total subsets of n items will be equals to 2 power n. Okay. Now, moving forward, there is this is just a simple question. You can see it. Next is, okay, it's a just a second. Yeah, there's one question like a committee of three is chosen from 8 people. What is P? Or what is probability of a person is Alice? there. Okay, so how you will do it? Just see the total number of way to choose 3 from 8, which will be done by combination. Okay, then again you will say like one person have removed from this in this step, so next will be 7c2, and by this you just multiplying uh, you will just multiply 21 by 56 you will do, and you will get the answer 3 by 8. Okay, next thing is that what are the mistakes that you can make while doing this kind of questions. First of all, forgetting whether order matters or not. This is like single most common error which we do in silly mistakes. Like always ask explicitly before choosing permutation versus combination. If there is something written like top three students, so here ordered is matter, okay, and versus there is something written like a group of three students, so a group can be something like ABC, BAC, or CAD, CAB. So unordered, it's unordered. It's completely different counts. Okay. Then second thing is like off by one on from n items means probability permutation nk draws from n without replacement by default. If we allow replacement, it is n power k. So these are two different formulas which you have to keep in mind. Okay. Then there is like overcounting and undercounting. This happens when problems have multiple constraints. Now it's easy to count some cases twice or miss case, like we have studied in inclusion and exclusion rule. So yeah, then there is one more thing. When like NCK is equals to zero when k is greater than n. Okay, NCK is equals to zero when k is greater than n. There's no way to choose more items than actually existing. Okay, students, like we sometimes plug in and get nonsense instead of recognizing it's zero by definition. Okay, then the next thing comes is why we are studying this, what is the ml connection of this. Okay, so in this combination appear directly in binomial distribution. Okay, the nck terms counts how many ways k successes can be arranged in n trials. It is a multiplicity factor, so it is also relevant in feature subset selection and ensemble methods. So that's all for this video. Next video, we will be covering classical frequentist and subjective probability. So, hope you liked my explanation. And if you find any mistake, you can just say me. Thank you. Bye bye.